Hello everyone. Today I am going to present you about the project explanation presentation about home automation system which is offered by the Emertxe. In this internship, I have learnt about the embedded systems and IoT and implemented a project called home automation system. Let us begin the presentation. The project title is Home Automation System. Myself, by Y.Sai Haran Reddy. I am currently pursuing my bachelor's degree in Electronics and Communication Engineering department, which is where in J&K College of Engineering, Kalakiri. I am very glad to be here to present you about my project. My project. What are the contents of my presentation are nothing but Internet of Things introduction, embedded systems basics, C programming, design tools, garden light control system, temperature system, serial time control system, and project simulation demo at the end of this presentation. And finally, conclusion. The design tools which I have used in this project is Arduino IDE, which we use it for the coding purpose, and the Pixim Lab, which we use for the virtual devices, and we connect all the circuit pins, everything in this virtual lab only, Pixim Lab. Here all the devices like any boards are all boards are available, all kind of devices are available, which we can connect them in the space parts, where you can also see in the modules oscilloscope and spare parts are available. In the spare parts we connect all the devices, and we use an mobile application Blink for controlling the devices from anywhere in the world. So let's get into deeper in our presentation about these two design tools. Firstly, I have learned basically in C programming in this internship. The basic structure of the C programming you can see here. The structure of the C program. It is the basic structure of the C program. Documentation required where the program demonstrate the structure of C. Here is just for commenting purpose. The the multi-line comment is mentioned by hashtag and hashtag symbol, forward slash and hashtag symbol, and hashtag symbol, and end by for hashtag symbol and forward slash. And also for single line comment, we just two forward slashes we use for the documentation or nothing but the commenting purpose. And there will be a header files which ends with .h. Hash include stdio.h is nothing but hash include standard input output header file. It is a preprocessor directive. And also global declaration is nothing but the declaration which is available globally for the entire program. So this where declaration is called, this kind of declaration is called global declaration. And functional declaration, where we declare a function at the starting of this program. This function can be used in the entire program at any time. Definitely every program consists of main function, where main function is mandatory. Without main function we can't write the logic in the C program. In the where we have here we have taken Fibonacci as a function. In this function we write all the logic which is required for the Fibonacci, and this implementation will be printed in the main program by calling this. Let us here see what this program is look about. Here we declared where int y, and he declared we function Fibonacci, and the variables int first equal to 0, second one, next one, I comma number. Enter a number. If we when we see this statement, it displays on the output screen. Then automatically when we enter any number, it scans it and gives a tab space for hashtag tab means for backward slash tab t means. Here we have written logic in the for loop initialization I equal to 0, condition where you have written I less than or equal less than num, and the incrementing or decrementing purpose, updating purpose, we have written I plus plus, which always increments 1. Here we have written next equal to first plus second is nothing but next we have written 1. 1 equal next. In this next we stores that first and second means 0 plus 1. It will be stored in next. And again this second will be stored in first. Means nothing but 1 will be stored in 0. Second next will be stored in second. Next will be stored in 1 will be stored in second. Means this one will be stored here. This one will be stored here. Now print on next means what will be the next? Next here we can see second. What the second is now? At the starting only for next equal to first and second we have written. So 0 plus 1. It will definitely prints 1 only. Okay. The topics in the C programming I have learned is data type, modifier and qualifiers, conditions and loops. Conditions like if else if ladder, multiple if, traditional if, those kind of things I have learned. The conditional statements like switch cases. These are the things I have learned in this internship. And the loop statements like for loop, while loop, do while loop, for loop and while loop, for loop and while loop are executed only after checking the condition, but do while loop executes one time before checking the condition. The main difference is that. And the operators like arithmetic operators, logical operators, like this kind of things we have known. Arithmetic operators like add, addition, subtraction, multiplication, division. Logical operators like logical and logical are like these kind of operators we have seen. Arrays and pointers, how to declare an array, how to declare a pointer, how to access the pointer, how the pointer is accessed with the ampersand symbol, how the address is taken. These all the things I have learned in this internship. And the functions, how to declare a function, how to call the function, those kind of things I have learned in this internship. Storage classes, how to declare the storage classes, where how storage classes are useful, and how the preprocessor, these kind of all the things I have learned in this internship. Firstly, let me introduce about the Internet of Things. Internet of Things is nothing but the word itself says Internet and things. The connecting the things with the help of Internet, it is called Internet of Things. Simply here we can also see that the network of physical objects that contain embedded technology to communicate and interact with their internal states or the external environment, whether to interact with the internal devices or else with the external devices, external environment, we say that it is an Internet of Things. Just we have to remember Internet of Things nothing but the things which can be controlled by accessing the internet. Okay. There are the many applications from the home, wherever in home, workplace, or in, like we can see medication adherence, child and elder monitoring, this kind of devices, sports and fitness, health monitoring devices, pet tracking devices, behavior modifications, object tracking, trip tracking and car health, beacons and proximity, indoor navigation, office equipment, identity, food and nutrition tracking, smart appliances, sleep tracking. Sleep tracking will be helpful for the people who suffering with the sleep deficiency, and home security. Wherever for if any theft thief comes to our home and stealing something, we will get a notification by this kind of things. We can use Internet of Things in home security. Home automation, everything can be controlled by the with our mobile. This is called nothing but home automation, like controlling fans, lights, everything with the help of mobile itself, like heater, cooler, those kind of things. Leak detection, wherever the leaks in the pipe, we can use this Internet of Things. Air conditioner, environmental sensors, information capture, control, entertainment systems, new device and sensors, wherever you can see, everywhere you can apply this Internet of Things, which is a combination of the hardware and software. Nothing but we can say Everywhere, if there is a embedded system, definitely we can control this by using internet. Then we can make it as a internet of things, right? The applications of the internet, right? The applications like example automobiles, as we already know, manufacturing devices in manufacturing and logistics and transport. For business purpose, many devices has been used in this internet of things. Examples are wearable health monitors like watch, which tracks our health, like how many steps you have made in the day, how is your oxygen level, how your heartbeat is. Like this wearable health monitors you can see. And smart cars which nowadays Tesla cars are famous, which automatically drives itself without the help of the driver. We can travel in the car without driving. It itself drives the car without accidents, and monitors all the things inside whatever happening in the road, location kind of thing. Smart buildings, everything will in the building is a smart, like everything fan, fridge, oven, lights, gateway system, door locking systems, everything in the building is the smart means then it is called a smart buildings. Home automation is nothing but as I already said, at the door locking system, water tank control system, heater, cooler, everything will be controlled automatically with the help of our mobile itself. We can control all the things. That is nothing but home automation system. Let's get into deeper. And also, where if there is existing a internet of things, definitely there should be a embedded system. Embedded system is nothing but it is a combination of software and hardware which is designed for the specific purpose. It is called embedded system. In embedded system, there is the internal architecture will be look like this, where the sensors collects the data which is in the analog form, and the actuators will given the gives the data in the digital form, like in the displays. Wherever we can see in displays also we can consider as actuators, and also motors. These kind of things we can say as actuators. Sensors we already know, ultrasonic sensors, IR sensors, motion sensor, heat sensor, those kind of things we can use as sensors. And the actuators like those kind of analog to digital converter, which converts the signal which is information convert gathered analog form in the from the sensor will be converted to the digital form and gives to the processors. ASIC process is nothing but application specific integrated circuit and processors which for the user for the special purposes. And the memory, these both are interfaced with the memory. All the things converted travel into the required format for the desired output. Then later it converts into from digital to analog converter. We use digital to analog converter, and then the output will be displayed on the actuators. Let us see what the sensor is. Sensors measures the physical quantity and converts into electrical signal, which can be read by observer or any electronic instrument. Analog to digital signal, you already know as the name says, it converts analog to digital signal. Process which process the measurement output for the desired one and store it in the memory. Digital to analog converter is nothing but as the name says, it converts from digital to analog. Actuators compares the output given by the digital to analog converter to the actual output what that's stored in the approved output. We give both the actual output and the expected output. We have to be more accurate that expected output should be similar to the practical output. These are the applications of the embedded systems like mobile phones, tablets, washing machines, laptops, TVs, refrigerators, air conditions, Wi-Fi, traffic lights, aeroplanes, digital clocks, debit card swiping machines, ATM machines, printers, space shuttles, missiles, house cleaning robots, micro oven. These kind of things, all the things comes under the embedded system, which does only for the specific task. Refrigerator, it is only for the cooling purpose. Microphone we don't call as microphone, and mobile phone and the PC we can't say as it's a embedded system. But yes, in sometimes only we can say. But washing machine only cloths the wash. Air condition only cools the climate. Wi-Fi only provides the internet access. display clocks only displays the time. Traffic lights only used for the lights purpose. For the anything that is used for the specific purpose, then it is called as embedded system. Now let us get into about Arduino Uno. In this internship, I have learned about this Arduino Uno and programmed this with the help of Pixim Lab and the Arduino IDE software. The software I have used is Arduino IDE and the language I have used is Emertxe and C++. The architecture pins, you can see that these are all the digital pins which were used for the pulse width modulation purpose only. These pins and the analog pins from A0 to A5. These are the pins. And for power supply, 3.3 volts, 5 volts ground V. These are the power supply pins as you all can see in the figure. This is for the power cable and this is for the reset button. USB cable is connected here and for it is for the reset button. If anything wrong happen, we can reset the board. This is the Arduino Uno board where we dump the code by using USB cable here. The architecture contains digital pins, analog pins, power pins, analog to digital converters, and everything. Oscillators, pulse width modulation pins, everything. Arduino IDE is nothing but a microcontroller board based on Atmega 328. Here you can also see that there is an IC which is called Atmega 328, which is microcontroller responsible for this all the functions. It has a 14 digital input output pins. These are the 14 digital pins and 6 analog pins. It is operated under the 16 megahertz ceramic resonator, a power USB connection, a power jack. It is called power jack. A black. This is black one, and it is a reset button. It can be programmed using different IDE. Arduino IDE is used in this project. I have, as I already said. Next, project simulation. I have done the projects as it costs more heavy cost for the hardware equipment. So I have simulated in the software itself. For this purpose, I have used the Pixim Lab software. In this Pixim Lab software, it is a open source, means it is easily available and can be easily configured for the as per our requirements. Emulator. Pixim Lab is an open source real-time emulator of a development boards with integrated MP-LabX, AVR GDB debugger. These kind of things will be included in this open source Pixim Lab. It supports Pixim microcontrollers and some SIM AVR microcontrollers. It has integrated with Arduino IDE for programming the board's microcontrollers. For this purpose, we dump the codes, we write the codes in the Arduino IDE and dump the codes as a form of hex file with the using this USB cable. Unless we make the simulation by using these spare parts, we connect the spare parts and as per the requirements of our project, and simulation will be done automatically. The connections will be made as per our requirements for the project. Let's get into deeper about the project when the connections in the demo. The Blinkin IoT app. This is another design tool we have used for operating for easily access from our mobile. This app will be installed in our mobile and we create a new template and add that devices in this app by using buttons. These kind of things we can use sliders, joysticks, widgets, these kind of things for symbols, and select and add data streams. The data streams which we represent it as V0, V1, V2, V2 like this. We name that for specific purpose and name it for cooler separate, for heater separate. Those kind of things we will see in our project. Next, how to create an icon or button. Include blink in libraries in the code. How to include this blink libraries in our code. I have also learned these all the things I have learned in this internship. Home automation. This is our main project, home automation. Generally, people always don't stay at home, right? Everyone, some people will be in office, some people will be in this college, schools, like that. But if what else if someone forgot the heater in a home, or light all the lights will be on turned on while going out the home, we haven't noticed. Later after going for the college, then we remember that I have turned on So we unable to go back again to turn off, then the electricity will be wasted if it not turned off. So for that purpose, for easy accessing, in our in mobile itself, we can control those lights, whatever the applications in the home. By this, this is the main motto of this home automation. Like example, in our home, the lights can be controlled by the using home by getting a smartphone alerts when the heater is more heating than 50 degrees Celsius. Energy management, alarm control systems, temperature control systems, keyless entry for the door for theft purpose for protection, and motion detection sensors, controlling irrigation system, the gardening purpose. We can make any kind of things. Like also we can control water tank in our home, inlet and outlet valves. These are the things we made in our home. This is nothing but home automation. In my project, I have done three things: garden light control system, which enables the garden light and disables the garden light as per the requirement of day and night, and the volume of water present in the water tank, like whether the input valve has to turn on or turned off based on as per the requirement, the volume of the water tank present, how much the water is present in the water tank, and also temperature of the home, like by heating heater or cooler by turning on and off of the heater and cooler, maintaining the room temperature. These are the things I have made in this project, included in this project. Let's get into deeper in this. Firstly, let us discuss about the garden light control system. In garden light control system, we have to make the connections as per the circuit, like we have to connect the lights, LED lights, or else the lights whatever present in our garden with the Arduino board and the LDR sensor. LDR sensor is nothing but light dependent resistor. LDR sensor, LDR is nothing but which detects the light. The circuit diagram of this LDR sensor is like this. Here is our LDR. You can see. Usually, if you observe in a day, the sunlight will be more, right? When the sunlight is more, what about the resistance? The resistance will be decreases in a conductor, right? If the sunlight is more, resistance decreases. Here, if you can see, the output voltage is coming across is inversely proportional to the resistance, the LDR resistance. You can see, right? If the resistance is decreasing means, what about the voltage? Voltage and resistance are inversely proportional here, right? Resistance is decreasing means voltage increases. Okay, let us again by seeing next figure, you will get to understand. From here, you can say that voltage divided. Voltage divided is here the output voltage will be like input voltage into resistance voltage plus LDR resistance plus normal resistance. Voltage is inversely proportional to LDR resistance. We can say this. Here in this graph, by this you can easily understand this how the intensity of the light and how the resistance will be. As the resistance increases, intensity of the light also increases. For example, in a morning time, the afternoon, let us take afternoon as an example, like average sunny day, means the sunlight is falling, means then the resistance is low. Resistance is low means voltage will be more. Voltage will be more means automatically we have to program that if the voltage is more, then turn off the light. If the voltage is less, turn on the light. By this, by maintaining the resistance and voltage logic, we make this circuit. Let us see when how it varies in our project and the simulation. The properties of LDR sensor is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night, light is very low, so the LDR sensor detects the light and the light is turned off on. Here you can say that During the daytime, outdoor light is very high. So LDR sensor detects the light. It detects the light, and the garden light is turned off. So it senses that the light is already present. So you should turn off light. The LDR sends the message, turn off the LED. Whereas in the night time, the LDR does not detect the light, and it turns on the LED. Here you can say that in a dark time, the LED should be on. In average, then the brightness will be like this moderate level. Bright sunny light, then definitely it will, the light intensity is very low. It's nothing but it will be turned off. For the temperature control system, we use the one sensor. It is nothing but LM35 sensor, which it is also for the plastic where we have developed over it. We can use both the things in our most of the applications for temperature sensing purpose. For humidity, all the things can be sensed these kind of sensors. This temperature is recorded by LM35 sensor, which reads analog value. The temperature will be an analog value, which reads the temperature by this LM35 sensor. The value is converted into binary value, and then later actual temperature is calculated using the obtained value of the value voltage. There will be a formula for the calculating the normal voltage based on this binary value. The sensor does not require any external calibration or trimming to provide accurate of plus or minus 0.5 degrees at room temperature or plus or minus 0.1 degrees over the minus 50 degrees Celsius to 155 degrees temperature range. The output scale factor of the LM35 is 10 millivolts per Celsius. It is the main important point that the output factor of the LM35 is 10. How many volts means 10 millivolts only. For instance of provides the output voltage of 250 millivolts at 25 degrees Celsius. For 1 degree Celsius, 10 millivolts. For 25 degrees Celsius, 250 millivolts. Okay. Next, how the temperature system is connected. Temperature system, the connections will be made like this. We use here Blink IoT app also we use externally compared to that garden light control system. Here the how the procedure takes means the temperature system is nothing but the sensor detects temperature and gives the temperature in the binary format for the Arduino, and heat control and cool control will be done by this Arduino, and the notifications, all the things, temperature, how much the temperature is present will be displayed in the CLCD display. That all the controlling will be made by the Blink IoT app, which is a application in our mobile. Heat care control and cooler control. The notifications also will be sent to this Blink IoT app. How much temperature is present and everything. The connections will be like this. We can also see that how the connections are made and everything in the at the end of this simulation. The temperature system control system consists of heating resistor, an LN35 temperature sensor, and a cooler. These are the things we present. Actually, it's not our project circuit. The project circuit is different. It consists of heater, cooler, and threshold temperature maintaining one, and also LM35 temperature sensor. An analog value of the temperature is obtained from the temperature sensor and displayed in the LCD after converting into digital value. Actually, the temperature will be in analog form only, right? So it will detect and sends to the CLCD. Is in the form of, again it's converting from analog to the digital. It sends to the CLCD to display it. How much temperature is present in the room, like that. Control the temperature of the system by on or off of the heater and cooler through the Blink IoT mobile app. We can all control this on or off of the heater and cooler by just applying the Blink IoT. Serial water tank control system. In our house, there will be wastage of water when we don't see the how much of water is present in the tank. If it is less water means also we don't know until in the need. If we turn on the tap, if the water is not coming in, then we notice that okay, water is not present in the tank. It's a huge task. Again, we have to turn on the motor. Again, we have to turn off the motor when it fulls. For avoiding this all the burden, we make the serial water tank control system. It's in a smart way by using IoT. It is the volume of the water tank through serial communication and displays in the LCD display. control the volume of water tank by controlling the inlet valve and outlet valve. Inlet valve means when the water valve is less than 2000 means, then definitely the inlet valve is open and water comes into the tank. If the water tank is more than 3000 means, the capacity of the water tank is 3000, then it fills the 3000 liters means it will automatically turn off the inlet valve. And again, if we turn on the outlet valve until it becomes less than 2000 liters, the inlet valve will be off. If the water level is less than 2000 liters, automatically turns on the inlet valve and motor, and water will be get into the tank. This is the procedure of this our project. The tank refills when the outflow exceeds the threshold of minimum value 2000 liters, and it stops filling when the tank is full at 3000 liters. Given notification to the Blink IoT app. We'll get all the notifications in our Blink IoT app itself. This is the circuit diagram how it should be connected. Blink IoT water tank will be volume of the water tank will be given to the ordinary IDE, and again it will controls ordinary IDE will controls inlet valve and outlet valve by the help of the Blink IoT app. The notifications and volume of the water will be sent through the Blink IoT app. The notifications and also displayed on the LCD display. Volume and notifications and volume. This is the how it looks like the inlet valve and outlet valve. When the inlet valve, the water quantity is more than 2000 means the inlet valve will won't turn on. The outlet valve will turn if the outlet valve is turning on. The capacity if decreases less than 2000 liters, automatically the inlet valve turned on until it reaches the maximum capacity 3000 ml, 3000 liters. Like this procedure takes off. The control of the volume of water tank, here we do one more thing is, if the volume of the water tank is less than 2000 liters, turn on the inlet valve and send the notification to the Blink mobile app and display the same in the LCD display. Automatically it will turn on. If it fills, automatically turns off. It's the procedure we done. It is the simulation design how it looks like. Temperature, the current room temperature is 27.3 degrees 34 degrees Celsius, and the volume of the water in this is 2370 liters. The inflow is on, so that inflow on it is showing the display. If we let us see the how its simulation works. Let's get into project presentation window. Project presentation. This is our Arduino IDE where this is the Pixim lab we are using, as I already said. Here I have already loaded this code in this in this Arduino. So I have reloading the last one. Here we can see the simulation how it looks like. The current room temperature is 27.34. Again we are reloading the last one. Yes, we can see that the inflow is going on in the water in the tank. It is going on inflow on. You can display it in the LCD display. You can see here. Until it reaches 3000 liters, the inflow will be on only. After reaching the 3000 liters, it will automatically turns off. Yes, now it reached 3000 liters. So it automatically inflow was off. You can observe here, right? Yes. Okay, firstly, before going this, Let us see the first one project of our one. What is the first goal of our project is controlling the garden light, right? The LDR resistance, if the resistance is high, the resistance is high means light will be turned on. If you keep on decreasing the resistance means the light will going dim. You can observe here, right? Here you can see the resistance is keep on increasing, the LED light will be glows brighter. Keep on decreasing, the LED light goes turn off. By controlling the resistance, we can maintaining the in the night time it will turn on, in the daytime it will turn off. This is the main reason of this one. Controlling main LDR sense, light dependent resistor garden light control system. Our second one main goal is controlling the heater and cooler. Let us see this how we can control using the blink IoT app. Let me connect. We are using app power window for mirroring purpose. Yes, we have connected. In the blink app you can see that it is in online mode. If it is displaying the green color means it's showing that it is in online mode. Now let us see how we can control. In mobile, firstly I am controlling the heater and cooler. If I turn on the cooler, the fan will be rotating. You can see it is slowly rotating. You can also see that cooler on notification, and the temperature is 27.34. You can also see in the gauge in our mobile itself. If we turn off the heater, the fan will turn off, and here also reflects in LCD display also it reflects the cooler is off. Now let us turn on the heater. We have written a code for if the temperature is greater than 35 degrees Celsius, automatically it turns off the heater. That's the main code we have written for that. And turning on the heater, it is exceeding 35 degrees Celsius means automatically it turns off the heater. Here you can see the notification. The temperature is above 35 degrees Celsius. Turning off the heater. It has automatically turned off the heater. I haven't turned off the heater. It automatically turned off the heater. If you turn on the cooler, now it is until it reaches the room temperature, it cools down. This is how we can control the heater. If the temperature is above 35 degrees, it automatically turns off. The main purpose is that. Let us see how inlet valve and outlet valve controls. You can also observe here. If inlet valve is already the water is full, right? So I am turning on the outlet valve. The water is going out. You can observe here, and also you can it reflects on the LCD display also that outflow is on. automatically when it's turn on less than 2000 liters, it automatically turning on. You can also see the notification without turning on the inlet valve. It has to be automatically turned on. See, you can see the notification that turning on the inlet valve, tank is full, turning off the inlet valve. If the automatically fills means it turns off. Volume, the main code we have written that if the water is less than 2000 liters, it automatically turns on the inlet valve. Tank is, if the tank is full means up more than 3000 liters, up to 2000 liters, automatically turns off the inlet valve also. This is the main working of our project. Thank you. Thank you for giving this opportunity. I'm very grateful for having this opportunity from the Emertxe Institute. Everything that can be automated will, if it will be automated. Thank you.